Worlds are turning, and we're just hanging on, facing our fear and standing out there alone.
Please welcome Trish Damkroger.
Hello, welcome to Barcelona. How did you go to the keynote? Yes? How was it? Good, good. Okay, we're going to continue on the dialogue that Antonio started near the end of the keynote about AI. Just, not a very common word these days, just a new term that we're just starting to talk about just a little bit. So, since we were here a year ago in Barcelona, and even when we were in Discover Las Vegas, if you were there in June, the pace of AI continues to accelerate, it seems. What's happening with AI over the last 2 years has been something that I don't think any one of us could have imagined. And it's just a super exciting time to be in this business. So I just want to ask a couple questions. So my husband and I, we're going to be in Portugal. We're going to meet in Portugal on Friday. And normally, 2 years ago, I would have used the internet to search what to do, right? Now it's ChatGPT. I mean, my husband now insists I have joined the Gemini crowd. And so we're constantly, and he's the ChatGPT crowd, right? And so we're searching, like, what is the best hotel to stay in? Where's the best restaurants? And, comparing results. And it's interesting, Gemini, supposedly, if you read some of the language, OpenAI is a little worried about how Google is advancing faster. And I would say that I wouldn't see, well, I'll let you know after our trip to Portugal which one's the best one. Right? So who out there is using ChatGPT beyond planning vacations? Within your organization, do you have, like we have an HPE, Chat HPE, I think it's called, right? So does your organization have that internal? Okay, a few of you. What about writing software development? Any of your software developers using GitHub or Copilot? Are we using that within? That's allowed? Yeah, I'm seeing some. Okay, good. So I read, I think it was Deloitte that did their performance appraisals with AI Assistant. Anybody doing that? That is what I want. I mean, wouldn't that be amazing? Because of course, at HPE, our performance appraisals are aligned with the end of the year, aligned with our supercomputing conference. It's a crazy time. I could really use that. So I am starting to see AI helping us within our organization and also definitely helping in my personal life and competing with my husband, which is always fun. So AI has been around, since, and it's been growing. Like I said, the last 2 years, we're seeing this rapid growth in AI and really generative AI over the last 2 years. But that adoption was in 2023. And it's been really that drive with large language models and the growth that is needed both with compute and with all the data. And you'll see that in a McKinsey report, they're saying that it's growing 2x from 33% to 79% of the organizations are using AI for at least one function within their organization. I mean, like I talked about, we have Chat HPE, we have Copilot, GitHub Copilot for our software. So we're starting to use it, but I would say it's more functional versus across a unified experience. And I'll be talking about that actually tomorrow in a panel about, the importance of a unified strategy. But at least within one functional area, 79% of the organizations are using Gen AI. They're also saying that 58%, this is a Boston Consulting Group study, 58% of the employees stay up to 5 hours a week. You know, it's both like in your marketing and sales, doing content generation, it's your product and service deployment. In our service organization, we're using kind of a chat GPT to help accelerate what our service organization, just going through all of the documentation. Like, have you seen this before? What's the best way to fix whatever you may be seeing? Obviously, also the chat bots and customer support. And then we're also, like I talked about, in software development, using Gen AI to help mainly with testing. So developing test cases so that we can make sure that we accelerate deploying actually the software out there. So we see the growth in Gen AI. We're seeing it within our own organization. And we know that's important that we are providing a service to all of you to help you grow in your Gen AI journey. So let's give you some examples. So we have Alfalfa, which we've been working with for a couple years now. And they have developed, it's a startup in Germany. And they've developed a multimodal large language model in 5 different languages. And it's really targeting enterprises like healthcare and banking, manufacturing, automotive, et cetera. And they're one of the first ones that said, we need to be able to help you go from English to Spanish to Italian, German, French. Those are the 5 languages, and really help industries be able to move seamlessly across that language barrier. Or there's Zenseact, which is for Volvo. So this is self-driving cars. So this is the software to advance the driver assistance and the self-driving aspects. And they have trained across massive data sets and even simulated training data that they've developed through their modeling and simulation efforts. And it's really about improving the model accuracy and also being safer and smarter in the self-driving area, which of course we all want. We have the Magyar Telecom, and this is making sure this is really a national effort within Hungary. So it's making sure that they maintain the Hungarian language and the importance of that. It's one of the oldest and most complex languages. And so they're fine-tuning an existing LLM to create digital assistants in Hungarian. And then Bosch, probably most of you know Bosch, is a global leader in manufacturing and industrial technology. And they're committed to transforming their production capabilities with AI. So they've developed a digital assistant, or a digital twin, to actually run at the edge of their factory floor. And this is allowing them to reduce downtime, improve the operational efficiency. It can, with all that manufacturing capabilities. And it's also very much focused on sustainability. So they've done that, again, that digital twin at the edge. So these are just some examples of our customers that we've been taking along on this journey from model to building all the way through to inferencing. One of the conversations I was having yesterday is they say that 2026 is going to be the year of inferencing. So we'll see if that's really the case. I have some other ideas about that. So this is a growing market for AI training. We look at it in kind of 3 different areas. So the first being model builders. And this is, like I talked about it already. We have the OpenAI, we have Grok, we have Gemini, Google Gemini, Anthropic. So these are these people that are consuming massive amounts of infrastructure. And we'll talk about, how they're driving the demand for GPUs and power. And, one of the largest growing markets that we're seeing as far as if I look at where we're selling, and it's been in our largest growth over 2025 is in this segment, our model builders. Then we have the service providers, also known as neoclouds. And this is people that are providing infrastructure to those that maybe don't have it on-prem themselves. They're looking at, normally it's bare metal. They're not really developing much of a software stack on top of it. But it's people that don't want to manage their own infrastructure are moving into these neoclouds or service providers. This is also a large growth market, and where I would see we continue to see, I would say, outside of those large, really the large language model builders, this would be our second highest growth in 2025 that we've seen. And then the last is sovereign. Antonio brought up sovereign today, and I think especially in Europe, we're seeing a huge opportunity here in 2025 and 2026, where we see a lot of interest in the national AI efforts that are happening across Europe, but also in the US. In fact, an executive order came out, I believe it was last week, from President Trump talking about our national AI effort in the US. And if you're in Europe, obviously the EU has been very active in AI factories and gigafactories, and we're seeing those pop up all over Europe. So we kind of look at this growing market for AI training, and this is kind of how we have parsed it out and where we really look at what are the needs and how do we provide the needs, the infrastructure needs for these different areas. But the truth about training, I mean, when we look at what it takes to, it's not just the infrastructure, the size of the infrastructure, but it's the data sets that you're going to have to look at in order to train these models. 120 petabytes of data. This is for ChatGPT-5, right? 70 AI exaflops per second. And then the power consumption of 180 megawatts. That's what it took to train GPT-5. And we talk about, when I look at our exascale systems, that is where the world I come from in the HPC space and supercomputing, 30 megawatts was a big deal. When we talked about exascale, getting there, how are we going to have the power for that? We're talking 180 megawatts. We're talking, now when I talk with customers, we don't even talk about, 180 megawatts doesn't seem like a big deal because we're talking gigawatts. We're talking the need for 5 gigawatts to power these AI, not AI factories, but these AI large language model training. So it's just a whole different mindset of what we're seeing is what this world of AI and large language models is driving. So compared to GPT-4, GPT-5 was said it used twice the compute power. And so I think that's another thing. So when we look at the pace of innovation of what we're driving even with our GPUs, it's a constant, it's a 6-month to a 9-month cycle now of where we're seeing the next generation of GPUs coming out and the next generation of the compute power that's needed to drive such things, hence driving up the power. So what are the requirements? And why do I think supercomputing, the world that I came from, is an amazing basis for the AI training that we're seeing today? So you need strong scaling. So right now, when we talked about, in fact, Rami talked about this in the keynote this morning about networking and the scale-up network that we're seeing. They're bringing in 72 GPUs with NVL72, right? We're scaling up more and more GPUs, bringing together that shared memory because the models are requiring that much capacity and bandwidth. You need to be able to scale across the compute for that. And not only do you need to scale, you need to make sure it stays up because you don't want to have your language, when you're training your model, you don't need the system to go down. You need to keep it up and running. You need that resiliency. And so it's really important that you have that software stack that supports the model training efforts that you need. It's also important to have your sustainability and performance, because when I talk about 180 megawatts or gigawatts, we need to make sure that we're really working together to create the right performance and sustainability metrics and the cooling challenges. I'm proud that we have the only 100% fanless direct liquid cooling out there today in our EX and our supercomputers, and we need to continue to drive those liquid cooling technologies as we move forward. And then also, it's the expertise of standing up these systems. So when we talk about standing up supercomputers, this is what we've done for 50 years. So it's, I don't know, has anybody been to Chippewa Falls and the Cray Museum? Okay, a lot. So thank you, supercomputing customers, and Dan Foss for coming and visiting. I highly recommend it if you want to see kind of that whole history of liquid cooling from our very first systems, from direct liquid cooling, immersion cooling. We've kind of been through it all in our Cray legacy, and you'll see that in the machines from Cray 1 all the way up to our current EX system. And so having that background and experience, and even the VP of engineering today worked on every single one of those systems. Unfortunately, he is retiring the end of this year, but he's still going to be giving tours at the Cray Museum, so you can still talk to him about all that background and expertise. But it's important that you have that ability, that knowledge, the system engineering to bring up the installation and have that operational expertise. And that's what you'll see within HPE. So Antonio talked about this. Number 1, 2, and 3, very proud of maintaining the leadership in supercomputing, but also the energy efficiency and the investments in the factory where we have the most liquid cooling technology or abilities within our Chippewa Falls capability, and plus our Kutná-Hora here in the Czech Republic. So with that, we've talked about kind of the supercomputing background and the history, but I want to bring up one of my dear friends and talk about the work that we're doing with the UK's most powerful AI system. And Antonio also talked about this. And I want to welcome up Simon McIntosh Smith, who's the director of Bristol Center for Supercomputing, and talk to him about his experience that we've had with supercomputing and now with AI. So, Simon. Good to see you. So, Simon, we've been on this journey for a long time with supercomputing, but you were building the first big AI system in the UK. What were you looking for in the infrastructure?
Yeah, so we were building this really on requirements from the UK government. The UK thought, this AI stuff's really taking off, and we need to make sure that we're in there and that we're doing everything that's necessary. So we needed to build something fast, and we really needed to build a sovereign AI capability as well. And that sovereign AI, what does that really mean? It means the ability to train large language models from scratch entirely within your country, to be able to also control your own valuable data assets. So we've got lots of quite sort of personal data. We have the National Health Service in the UK, and obviously all of those are medical records of all the citizens of the country. And we really want to keep that sort of inside the country. We're seeing lots of other countries also developing these sovereign AI capabilities. So we wanted to be able to train large language models on this infrastructure. We also want to be able to run AI as well, not just train the large language models, but actually run them and use them, and then maintain the integrity of all of our data within the country as well. So to do that, we needed to build this new supercomputer, Isambard AI, which we've done with HPE's help. And we need to build at scale. So we needed something big enough that would allow us to train huge large language models up to hundreds of billions of parameters, but also to be able to do that power efficiently. Power is always a constraint. You've always got a fixed amount of power no matter how much you've got. So you'd really like to use all of that for compute rather than for overheads for cooling and things like that. And also we care about the carbon emissions of our service. So we wanted the whole thing to be as energy efficient as possible.
Okay, so could you share how's it going? You know, how the AI projects you're working on today and any results?
We can. So we're now up and running. So we've got a system in the UK with Isambard AI that's 10 times bigger than anything else we've had in the country before, 10 times. And that's a huge step forwards. And it means we can now run AI projects that just simply were not possible before. It's a huge step forwards for us. Even though we've only been fully open for a few months, we're already up to thousands of users and over 400 unique projects, which just shows how much pent-up demand there was for this kind of capability. And those projects include training large language models, running AI across all sorts of different areas. We've got healthcare, financial services, and lots of projects in the AI security and safety as well. And I can tell you about a few in that specific area. And we've got in the UK a group called the AI Security Institute. They're actually part of the UK government. And they've had a number of different projects running on Isambard. And just to call out 3 of them, one of them is looking at the issue to do with, as we're all using AI more and more, especially things like ChatGPT, and those sorts of AIs in a conversational way, there's a potential issue where maybe they start to influence us in ways we don't even realize. And how can you analyze an AI to see if it's trying to influence us and try and combat the sort of undue influence on the population? So that's one project. Another is also, because these large language models basically absorb the entire internet and everything else that's out there, potentially they could be used for some nefarious purposes. So they might be able to explain how to build a biological weapon or a nuclear bomb or something like that. And obviously you don't want that to happen, right? So one of the projects is looking at doing some fine-tuning after the training to basically put in the guardrails so that you couldn't get a Gemini
That's
or a
good.
ChatGPT or
Yeah.
something to tell you how to do something as dangerous as that. And then the final one, something else you may have heard about in the news, is it's possible to poison large language models, and you can sort of pollute the data so that maybe with nobody realizing it, they would then start to misinform or other sorts of dangerous side effects after the fact, and nobody would know. So that's another project that's going on, is really looking at protecting LLMs and trying to detect if they've been sort of altered in some way.
Wow. I mean, that's fascinating, some of the work. And a little scary, some of the stuff you're talking about. So one of the other unique things about Isambard AI was you deployed it in a mod pod, as we like to say, the AI mod pod.
Yeah.
So talk to us about why the pod and how this is helping you with sustainability efforts.
Yeah, this was really interesting, a very interesting aspect of what we've done. We had a couple of requirements. One was do this very, very fast, which has been quite an interesting challenge. And being very British, if you understand British people, you know what I mean. It's quite an interesting challenge. But also, we had a greenfield site. We basically took a university car park, and we could do anything we want there, but we wanted to put this new facility in as quickly as possible. We've got 2 pictures on the screen. The one on the left is the site at the beginning, and it was basically a university car park. We were digging the first hole in the ground on June the 3rd last year. June the 3rd last year, so 2024. The picture on the right is sometime this year. We finished the whole site. We had the site built, the pod built, the supercomputer built and up and running with real users on the system in July this year. So it was just over 1 year. It's a 5 megawatt site. So that's one of the things that the modular data center approach really enables you to move this quickly and to be very agile. There are lots of other benefits as well. We estimated the cost of actually building a traditional bricks and mortar building, and it was going to be 2 to 3 times as expensive. So it's a very cost-effective way of building a facility using modular data centers. And also, we would still be building it now rather than being in production. So it takes a lot longer. So instead, we've got users doing real science. today. To put some real numbers on that, to build the whole site cost us about £17 million, 17. That includes the cost of all the 5 megawatts of transformers that we've put in. And to have built a bricks and mortar building would have been about £50 million, so about 3 times as much. So that was a big benefit of using modular data centers. Also because, as I mentioned earlier, power is always a challenge. Modular data centers are very, very efficient ways of building facilities. So we think we've got an overall efficiency of about 30% by using modular data centers over a full building. So that was another big benefit. Something else that came with the modular data center approach, the design of the whole site, and the kind of supercomputer we've built with HPE is it uses direct liquid cooling. And that's been transformative. It's been a huge benefit. We get significant improvement in energy efficiency, which means we can spend that power instead on cooling the computer down on more compute. And to give you some idea of that, our previous supercomputers had a power usage effectiveness of about 1.5. That means there's about 50% overhead. Whatever power you spend to run the computer, about 50% more needed to cool it back down and do everything else. Now we've shifted to direct liquid cooling, and I've been looking at the numbers myself. Over the last few months, our PU is not 1.5, it's 1.06, 1.07. That's a 6 or 7% overhead, down from 50%. That's enormous. When you're talking about megawatts, that's a huge saving, and we can put that saving into doing more real work.
Excellent. I mean, this is just an example of an amazing collaboration that we had. And I remember visiting the site in the pouring rain as it was still being developed, and we were waiting for power. That was one of our biggest constraints. So I'm thrilled, and I can't wait to hear about more of what's going to happen at Bristol. So thank you.
Pleasure.
So with that, we want to talk about AI factories. And AI factories, see, I think that is going to be the word for 2026. But we're going to find out. Is it inferencing, AI factories? I don't know. But really, it's about building not only the infrastructure, but the whole solution, so that software stack along, so that it is easy for the users to produce the results. And I would like to welcome up Chris Davidson to talk a little bit more about AI factories. Thank you, Chris.
Thank you. Hello, everybody. Can you hear me? Okay. As many of you know and heard about, deploying, installing, and managing AI systems is very complex. Don't let Simon fool you, okay? But we're here to actually remove some of that complexity. Not all of it, because we want to work with you on the complex stuff, but we want to remove some of that complexity. And we're going to do that with our 3 AI factory options, one of which you did hear about during the keynote. That's going to be our private cloud AI solution. This is very much a turnkey solution, rapid deployment, very prescriptive, very much focused on fine-tuning and inference and model deployments of a certain size. Where we've spent our time, though, is in the more customizable space on the fully integrated infrastructure, services, control plane, and everything that kind of wraps together, which gives us the tools to work with you and then meet and design systems for your users no matter where they are on their AI journey, whether that be large language models, generative AI, huge, huge, huge models that they're building, many models that they're building, all the way through to inference, RAG, and everything else that goes with it, right? So this is something that we kind of come together with you, and then we kind of drive that custom approach. Our AI factory solution for at scale is very much going to be focused on model providers and service providers. This is multi-tier, multi-tenancy. This is very much focused on tenants, subtenants, and groups, where that is tantamount to success. Without that, you would not be able to serve the many as a service provider. You'd be serving a single customer, which that exists, sure, but it's not the norm. As for the sovereign AI factory, we've taken everything that we've learned and deployed for the at-scale solution and built on that to include the governance to make sure that we're meeting the regulatory requirements for each country or sovereignty, right? So that we can stay focused on things like GDPR, NIS2, all the ISO and IEC requirements and certifications that are many per country or per sovereignty, especially since we're sitting in the EU, it varies greatly. And we recognize that so that we can stay focused on what matters for those sovereignties, whether that be economic competitiveness, national security, or as we mentioned with Aleph Alpha and the Hungarian deployment, that autonomy around cultural aspects and linguistics. So let's look at the software stack and the services that we develop for the AI factories at scale and for the sovereignties. Starting with the infrastructure layer, we must recognize that having a strong foundation is very, very, very important. And yet with the AI factories, this needs to be scalable, secure, and flexible enough when it comes to the regulatory and growth aspects of these organizations and countries. Our XD portfolio and rack scale portfolio with our silicon partners AMD and NVIDIA is that foundation that we use to build on, whether this be the rack scale GPUs or the 8-way configurations or single GPU configurations that we provide in part of this portfolio. Of course, this includes HPE storage and networking and direct liquid cooling options, which is becoming more and more important. Building on that strong foundation, one of the new features we're providing is a unified control plane with HPE Morpheus. For me, this is very exciting. For those that were born in the cloud with a credit card and it just works, this is that control plane that gives that cloud-like experience and kind of obfuscates all the complexities that we build with you or for you underneath, right? And it provides everything that you're looking for, that multi-tier, multi-tenancy, the automation, the infrastructure management, access to service catalogs, and billing and metering. Everybody's looking more towards as-a-service deployments. This becomes more and more important. This provides that infrastructure. The top of the stack, this is where things get very interesting. This is extremely customizable, right? We're looking at AI workflows, apps, frameworks, and runtimes. This could be an NVIDIA NIM, which you heard Antonio talk about during the keynote. This could be your own built container. This could be including CPE. We talked about this. Simon, we were talking about that a second ago. Or it could be the integration of your specific toolchain or your user's toolchain into how you want to deploy or how they want to deploy their runtimes or their workloads. Of course, when deploying a multi-tier solution like this, having the visibility and the security is very important from top to bottom, left to right, and HPE OpsRamp provides that observability with a full stack of predictive insights and visibility into everything that's going on. This helps with maintaining your governance and your IP top to bottom. And to round it all out, our award-winning HPE services. We have a worldwide approach for on-site and remote support 24/7 to help with the design, planning, deployment, and management of these solutions from the human perspective, something that is typically overlooked, right? So ultimately, we think that this is a framework that is secure, scalable, and flexible for developing these types of AI factories. Okay, we also talked about direct liquid cooling with Simon and in the keynote, and I don't want to ruin it, or rather it's already been ruined slightly, but I'm going to roll a video.
As data surges, chips grow denser, and the AI race heats up, one thing is clear: liquid cooling is ideal today and essential tomorrow, bringing improved sustainability to breakthrough performance in the data center. Liquid cooling magnifies the natural thermal conductivity of water, cooling the most powerful supercomputers of our time to deliver the insights we need. At Hewlett-Packard Enterprise, our expertise deploying liquid cooling solutions spans 5 decades. As industry leaders in supercomputing, HPE reimagines your compute with an innovative HPC system that brings cutting-edge cooling solutions to your entire data center, providing the power, density, and efficiency that your workloads demand, while leveraging opportunities like heat recovery. Whether your data center demands 10 kilowatts per rack, 200 kilowatts, or beyond, HPE offers a portfolio of pre-configured liquid cooling solutions, tailored with expert guidance and on-site installation to support you doing more with less.
So we're proud to continue that innovation, that 5 decades of innovation, over 5 decades of innovation. Let that sink in. We've been doing this for quite some time. And we recently announced the next generation in advanced direct liquid cooling. This sidecar pump drives a denser approach and 2 times more efficiency when it comes to liquid cooling, and a very modular approach so that when you're doing break fix or maintenance, you can remove a single pump or multiple pumps without having to take the rack down. This means that you can stay in operation, no problem. And if you've ever had DLC in your labs, you can understand that can be a problem, especially when it starts to rain. Trust me. In addition, we provide optimized cooling, so you can control the flow rate of liquid based on the type of compute and with workload fluctuations, so highly customizable. And probably most important, since we are in Europe, higher thermal capacity, up to 40 degrees centigrade. We know this is especially important here, and it means that you don't have to spend extra power on the chillers or the refrigerators required to keep your system cool. All in all, this has been built to make DLC, or liquid cooling in general, easier and more approachable for you and for our customers. We also talked about the mod pods, or MDCs, or AI modular data centers, many names for this thing, right? The idea here is not only how do we cool the systems, but how do we make them faster to access so that it can get in our users' hands to drive insights faster. University of Bristol sped up their deployment by 3x and achieved a PUE of less than 1.1. That's fantastic, and we're hoping to do that at many more sites around the world, and we will continue to do that. I encourage you to check out the mod pod on the show floor. You have to ask maybe Nahren where it is, because I haven't seen all of the floor yet. It's quite large. But again, this is about getting this into your hands and our customers' hands faster. But enough from me. Let's hear from another customer. Hudson River Trading, a global quantitative trading firm, trades in over 200 markets, and for over the last decade have been using AI, deep learning, and neural networks to drive positive outcomes, aka profits. And nearly every trade is influenced by a model that they have developed. Please join me in welcoming Compute Systems Lead at Hudson River Trading, Gerard Bernabeu-Altayo.
Hey, Chris. How are you?
Good to see you. Very good. You've been investing in AI for quite some time. Can you tell us about that journey, the growth, and the goals that you have through that?
Yeah, absolutely. So we've been doing AI now for almost 20 years at HRT, and we really need AI like every day, right? So we get a lot of data from the markets. We've developed our own models, our own systems, our own infrastructure. So everything you were showing earlier, we have all those stacks that we run ourselves. We customize it, and then we use AI to really get a lot of data and turn those ideas into live trading strategies. So those live trading strategies mean that we can then be more effective in the markets and, at the end, turn some profits, making the markets more efficient as well. Right? So our goals ends up being like the speed. So the fastest you can really take data, the fastest you can really turn that data into ideas, into models, is the faster that you can really improve your ideas and improve the markets with it. So with that, I would say like AI is really essential into our day-to-day nowadays.
Nice. And you did raise your hand when Trish asked if you were using AI in your organization. I saw that.
Yeah.
We've also been working a lot as of late, and we recently deployed with you a very large, a new AI cluster. Can you give us a little insight in some of the initial results?
Yeah, absolutely. I mean, we're very excited. We put together over the last few months, and we have a lot of B200s online right now. With them, we managed to get about 60% faster compute. It's not just the new GPUs, it's also the new networks. It's using the latest and greatest AMD CPUs with them as well that really help us accelerate the cycle, right? So with them, we managed to really move from having a new idea or wanting to build a new model or fine-tune a model, like really 60% faster, which it's very beneficial to our researchers. Because at the end of the day, we're here, we have our own researchers at HRT, obviously, so we invest a lot in getting the best people out there to make sense of this world that gets more and more data every day. And giving the best tools to them is essential for us. So with that, we try to live not at the bleeding edge, but at the leading edge, and we can do a little bit of both.
Yeah, very good. The new silicon that you've adopted and put into your lab is driving heat requirements and more power. How are you addressing the cooling and power requirements?
This is going to be another DLC story at the end of the day, as you will see in that image. But this really started years and years ago. It means a lot of planning, right? Like when you need whatever number of megawatts, you just don't get them on your home outlet. You have to really plan for it. And then we did air cooling to immersion maybe about a decade ago. We still run some immersion, but we've been moving to liquid cooling, to DLC for the last few years. It really helps us improve the PUE. It helps us use warmer water, helps us direct that heat directly into the chips that need that cooling the best. So with that, we make the most mindful, I guess, use of the resources we've got. So we need a lot less energy, and we really end up using more energy because that allows us to put more compute. Right? DLC also enables us to put the compute closer together because as you can see in those racks, those are like over 100 kW per rack. So we can really put a lot of GPUs close by. It shortens cables, it shortens the needs for space, so really lets us focus in what truly matters, which is building the biggest kind of supercomputers we can build with the least amount of waste possible.
Show of hands of who here has actually cabled something like this before. Shorter cables matter, trust me. Yes. Last question. Are those Juniper switches at the top?
Not yet. I would
Okay.
say not yet.
Need to work on that?
But you can see they're not DLC. That's actually a huge pain, right? Because that means we need to cool the room somehow. Like in this room, we really get just power and water, and we do everything else. So
Yeah,
gotta
fantastic.
work on that.
All right, well, thank you for sharing your experience.
Absolutely.
Hope you enjoy the show.
Thank you. See you.
And with that, I'm going to invite Trish back to the stage.
Thank you. So I think it's one thing for Chris and I to stand up here and talk about the stuff that HP is doing and what our customers are doing. But it's a whole other story when we have our customers come up and talk about what they're doing. And so thank you so much, Gerard and Simon, for sharing your stories. And I really think they do a much better job than Chris and I do about talking about the capabilities that we can bring to life for everyone out here. So it's about decades of expertise to power this next wave of AI. We talked a lot about liquid cooling. And I don't know, some of you might have been at SC. Do you even know what SC is? Supercomputing. It was in St. Louis 2 weeks ago. And if you went on the show floor, so this was a traditional HPC conference, right? It's over 30 years. And the show floor now is probably twice, and I say the other 50% that was there was liquid cooling technology providers. It was crazy how important liquid cooling has become just in this growth with AI, the growth with power needs, and the importance of it. So it was exciting not only because I've been part of supercomputing for way too long, but also just to see that importance of what we've been doing for over 50 years. And it's really about enabling the future of AI, which is so important. So whether you're just starting your AI journey or whether you've been doing it like our amazing customers for years, or want to continue to do it for years. So we're hoping that we can be your trusted partner. I want you to look at some of the other opportunities to talk. You'll see that direct liquid cooling is one of the sessions to talk about, but there's also AI factories. In fact, we'll be talking tomorrow up here, a panel discussion about what CIOs or CXOs are looking at for AI. And our modular data center, as we said. So go to the show floor, check out demos, please come talk to us. We'll be outside if you have questions for us. And really, I want you to enjoy the rest of Discover. But one more thing before you leave, we want your feedback, because we will take the feedback and hopefully, make the sessions more and more pertinent to what you're wanting to hear about. And of course, so if you loved it, give us feedback. If you didn't, don't bother. Okay, thank you so much. Enjoy Discover.
It's our body, we can do what we want to.